In this video, we are going to take a look at how we can integrate Laravel Reverb into a Next.js application. In the last video I made, I demonstrated how we can utilize Laravel Reverb using a practical example where we can send and respond to notifications to other users in real time. That example uses the monolith approach, where the front end and back end are in the same repository. We use Laravel Breeze for our default scaffolding in that example. After a while, I received a couple of messages from people who asked me how or if we can implement this feature if the front end is separate from the back end, which is commonly referred to as a decoupled architecture. And the answer to that question is yes, we certainly can. But unlike the monolith approach, since most of the configurations are already set out of the box, integrating this into a separate front end requires a bit more work and configuration. But it's 100% compatible with other frameworks and would definitely work since it adheres to open protocols for WebSocket servers. Whether your front-end framework of choice is Next.js, Nuxt.js, Gatsby, Svelte, or even Angular. Okay, in this example, I created a simple chat application to demonstrate this. Our entire front end is built with Next.js 14, and our API is powered by Laravel 11. So on the left, this is the product owner, Jake, and on the right side is a software engineer named Kiara. So at the top, we have a message icon, typical of messaging applications. So let's try to send a message to Kiara. And where is she here? Okay, she's down here at the bottom. Let's click the send message button. A pop-up dialog will appear where we can compose a message. So let's just say, hey, what's up? When we click send, you'll see our message notification pop up at the top. There's a subtle animation and an alert notification sound as well. Let's try it again. Send message. Another one. Send. And there's our message. So when we click this message icon, we will see a simple list of all messages here. So okay, like I said, our front end is built using Next.js 14, and our API is powered by Laravel 11. So in this video, we will learn how to use or set up Laravel Reverb for real-time communication using Laravel 11, configured as a back-end API only. It doesn't have any front-end scaffolding. And our front end is separate from our backend, which is Next.js. Our approach here is commonly referred to as the decoupled architecture, where the backend codebase is separated from our front-end codebase. And I think it's worth making a video about it because it involves a couple of steps to successfully integrate Laravel Reverb on a separate front-end framework like Next.js. So these are our two codebases. On the left, this is our Laravel API, and on the right, this is our Next.js 14 codebase. You can see in the composer.json file that this is Laravel 11 at the time of this recording, and in our Next.js app, this is Next.js 14.2.3 at the time of this recording. So now, the front-end scaffolding I used is Laravel Breeze. This is the official package or authentication scaffolding provided by Laravel for Next.js. If we zoom in and visit the official GitHub repository, you can see it says that this is the authentication starter kit front-end in Next.js for Laravel Breeze. So if you want to use this, you can follow the instructions here. In the introduction, it says this repository is an implementation of the Laravel Breeze application and the authentication starter kit. It also includes Laravel Sanctum to make it easier to pair our Next.js frontend with our Laravel backend. But this is entirely optional. If you want to use your own files or project, you can do that as well. We will only discuss how to implement Laravel Reverb to use in our frontend framework, which is separate from our backend. So in the README file, you'll find the installation steps. They are pretty easy to follow. Alright, let's get started. Okay, first go to the terminal and navigate to the root directory of our Next.js application. Let's install Laravel Echo and the pusher package. Run npm install Laravel Echo and pusher.js. Laravel Echo is the official package library that makes it easier for us to subscribe to channels and listen to broadcasting events coming from our Laravel-powered backend. After the installation, once you have set up Laravel to serve just as an API, install the Laravel broadcasting package by running php artisan install broadcasting. I've already installed it, so I won't have to do it again here. So let's go back to our NextJS application and run our development server with npm run dev. Once it starts, check it in the browser and refresh both browsers. Okay, it's working. Then don't forget to also start our Laravel backend server with php artisan serve. So our Laravel backend server is now running on localhost port 8000, while our NextJS server is assigned to port 3000. I'm just going to log in both of our users. Okay, I've logged in as a product owner on the left side, and on the right side is another user who is a software engineer, for example. By the way, if you want to use the project files I'm using here, I'll link them in the video description. This way, you can try it yourself if you want to follow along with what I'm doing here. In the Laravel codebase, I've also included the database seeders, so we have some example data to work with. Okay, let's begin. The first steps we'll take are copying the configuration files of Laravel Echo into our Next.js application. So in the environment files of our Laravel application, if you install Laravel Broadcasting and Laravel Echo during the installation steps, Laravel will automatically provide these values. Copy them. Then, in our Next.js application, paste them into the environment file. And let's just match the values to the pattern used in the Next.js env file. So each line should start with the keyword next_public. So, line by line, paste the values like this. Next, let's copy the Echo configuration settings so we can initialize Laravel Echo in our Next.js app. Okay, here, create a temporary file in the app directory called echo.js. Paste the settings here. This will be temporary, and we'll reference it later when we create a custom hook to call Echo for broadcasting or to receive events from the server. Modify the configuration settings here. Instead of import.meta, we'll use process.env. And of course, we'll change the names of the configuration values. Instead of vt underscore, we'll use next_public_, like this. We'll match the configuration keys in our Next.js env file. Okay, the next step is to go to our Laravel API codebase. Under the channels route, change the channel name where we'll subscribe to real-time events. Let's name it chat, and also ensure that the broadcasting connection is set to reverb in our env file. Then go to the config file and check the course configuration settings. If Laravel is properly configured to serve as an API only, you should see the local host and port 3000 in the allowed origins where our Next.js app is running. Make sure the supports credentials variable is set to true. Now, another important step we need to do, and please be patient guys, because when our front end is separated from our back end, we have quite a bit to configure to make our project work. So in the browser, let's visit the official Laravel documentation. Go to the Sanctum documentation. And then under SPA authentication, at the end, there's an authorization private broadcast channel section. Here, there's a couple of steps we need to take, particularly registering the channels route in the middleware. So let's copy the with broadcasting method. Then in our middleware, which is located in the bootstrap directory, open the app.php file. We need to disable the channels entry here in the with routing function. Scroll down and paste the with broadcasting method. This registers our channel's route to properly resolve to our API endpoints. Since we are using Laravel for API only, we'll automatically have an API prefix in our endpoints. Next, we need to handle the pusher authorization request to ensure that our authorization request will succeed when initializing Laravel Echo from our Next.js frontend. So let's copy the authorizer function of our Echo configuration. Then go to our Next.js app. In our Echo instance, under the key option, paste the authorizer function here. We can delete the options argument. We don't need this here. And as you can see, this calls the endpoint API broadcasting off, which includes the API prefix. This is because our Laravel backend is configured to use API only. So all API endpoint will automatically include the API prefix. So after all these configuration steps, let's go to our browsers and refresh the pages. You'll notice that our message icon is in the navigation. This is where we'll listen for events from our backend to receive messages from the sender. In the navigation file, I have some pre-built functions here, such as playing a sound and triggering animations when we receive messages, as well as a couple of states. Upon loading this component, we make an Axios request to fetch the unread messages. In our library folder, there's an instance of Axios created already if you use the Breeze Next.js scaffolding. That contains basic configurations such as our base URL, which is localhost or 3000. And we also have headers configurations and more. This instance is used for every HTTP request. You'll see in our navigation file that it is imported at the top. Inside the useEffect hook, this is where we are going to listen for real-time events. So what we are going to do is use Laravel Echo in the useEffect hook of the navigation component, so that when our component loads, it automatically listens for real-time events from our Laravel API. To do this, we'll create a custom hook for Laravel Echo. In the hooks folder of our Next.js app, there's already a default custom hook provided by the Laravel team if you use the Breeze scaffolding for Next.js. It's pretty basic and is used for login requests, reset password requests, etc. Now let's create a new file in the hooks folder and name it echo.js. So in this file, let's create a function called useEcho. And also create a state called echo instance along with its setter function, set echo instance. Let's initialize it to null. Under the useEffect hook, this is where we'll initialize Laravel Echo. Now in the temporary file we created earlier in echo.js inside the app directory, let's first copy the import statements. Then we'll place our echo instance in the useEffect hook. We'll update the echo instance state using set echo instance. And set it to echo. Finally, let's export our useEcho function itself. And of course, don't forget to return the echo instance state here. So it's a pretty basic custom hook in React. Now inside our navigation component, let's import our custom hook. To initialize it, let's create a variable called echo equals useEcho. Then inside the useEffect, we'll use it here. We'll check if the echo instance has been initialized. If it has, That's when we'll call our private function to subscribe to our chat channel. Using echo.private, specify our channel name. If you watch my recent video about Laravel Reverb, you know how to do this. Then we'll call the listen function, specifying the event name where our echo instance will listen. And the event payload will contain the content of our event. This will be the messages, the sender, and so on. For now, let's just log the content of our event payload to the console. And let's name our event, say, message sent. So next, we need to create this event class in our Laravel API. Let's modify our console logging a bit. Let's say real-time event received. Now let's create our event class to broadcast the event to our front end. In our Laravel codebase, let's close these tabs for now. Then in our terminal, let's create an event using PHP artisan make event. Let's name our event message sent. This is what our Laravel backend will emit to our NextJS frontend. So after that, we'll have a new event class in our app folder. Under the events folder, and this is our message sent event class. First, don't forget to implement the should broadcast contract. This is essential for broadcasting our event to our front end. And then in the broadcast on method, let's specify the name of our channel, which is chat. Then we need to specify the ID of our receiver in our channel. Before that, inside the construct function, let's place the payload of our event. This is the data we'll broadcast to our front end. First is the receiver. Let's declare it as a public property. Second data is our sender. And the third is the actual message we'll send, which is just a string. Now back in our channel name, let's specify the ID of our receiver who will receive the message. This way, we can properly broadcast the event to the correct recipient. So when you revisit our channels route, you'll see that we have an ID parameter here, or argument, to verify who can listen to our channel. Okay, our event class looks good now. The next step is, of course, we need to broadcast our event to our front end. Here I've created a basic chat message controller. And in the store method, this is where we're going to broadcast the event to our front end. First, let's construct the payload we'll send. Fetch the receiver, who is the recipient, of course, of the message. Then the sender of the message. Now let's call the broadcast helper function and instantiate the message event. Then we'll need to pass our arguments, which are the receiver, the sender, and the message itself as the third argument. Finally, we'll just return an empty response using the noContent function because we don't need to return any data in our chat app. All the payload is broadcasted to our front end. Now, our API call to send message is executed here on our dashboard page. I've already written the code to save some time. Here's the Axios request to send a message. We'll simply pass the necessary parameters, the user ID of the receiver who sent the message, and the actual message itself. Pretty basic. Then down here in our modal, we call the function. We have a text area here. And at the bottom, we call the send message function. Let's try it out. First, let's start our Reverb server. In the terminal, in our Laravel API root directory, execute the command php artisan reverb start. Then pass an additional flag, the debug flag, so we can see the incoming events. Make sure our backend server is running as well. We also need to start a queue worker. Say php artisan queue listen. Okay, in the database, we have a chat messages table. This is where our messages will be saved. Okay, let's try it out. In our browsers, let's refresh the pages. Then let's open the browser console to check if there are any errors or if we are receiving events from our backend. Let's send a message to Kiara. And where is she? Okay, she is at the bottom. Let's send a message. Let's say, "What's up?" Send. And the message isn't being sent to Kiara. So what could be happening here? Well, the issue is that we need to pass an authorization token to our broadcasting authentication route. This is another step we need to do in order to make this work. So we need to configure our Laravel backend to issue an API token that will attach to the header of our request to authorize us to access our broadcasting route. Fortunately, this is very easy to do in Laravel. So let's go to our Laravel codebase. In our user model, all we need to do is use the has API token straight, which is already available in Laravel Sanctum when we configure our backend. And next, for every logged in user, we'll attach the API token to our responses in the Authenticated Sessions controller. Here you will find the method for user login. After the regenerate method, we'll attach our token here. So let's say token, then in the request, then we'll get the currently authenticated user, and then create token. Let's give our token a label. Let's just say API token. And then we'll output it into a plain text token. Let's return the response. And then in the response, we'll add a cookie. And here we'll attach our token. Then we'll pass the token variable. In the third argument, we can specify the expiration time of our token. For now, let's say 60. You can also configure it as a non-expiring token. But for our example, let's just say 60 minutes. And let's comment out this response below. Okay, it's time to intercept this in our front end. Let's go to our NextJS codebase. Remember, we have an Axios instance created in this file. Here, we'll attach our API token to the headers. This is our Axios instance. And remember, in our custom hook, we call this API broadcasting auth route. So we need to attach our authorization token in the request header, which we created earlier. Let's go back to our Axios instance and create a method called setBearerToken. Say axios.defaults.headers.common, and the type of the header is authorization. And this is going to be a bearer token. Using string interpolation, we'll pass the token here. This is the label. And of course, we need to accept the token as an argument in our function. So this function is setBearerAuthToken. And we need to export these two name exports from the module so it can be used in other modules. Since we changed the export, we need to update all our import statements of Axios. First, in our custom hook, then in our navigation component, and here in our dashboard page, we also use Axios. And finally, in our auth custom hook. In our authorization hook, we'll also export the setBearerToken. So we can use the function here, because this is where we are going to intercept the API token from our backend. This is where the login route was executed. So here below, we have our login function. As you can see, after we log in, this is where we fetch our API token. So set bearer token, then res.data, and then the name of the token is token. Remember, this is our login route. So now every time we log in, our API token is automatically set in the header. And here in our custom hook for Laravel Echo, in our post request to our API broadcasting authentication route, our token is automatically attached to the header. Okay, after all of this setup, this is the moment of truth. Let's go back to our browsers, refresh the pages, and let's try it out again. Let's go down here. Here is Kiara. Let's send a message to her. Send message. Let's say, hello there. Send. And then you'll see here in our console, here's our real-time event payload. So without refreshing the page, we receive the payload. So the final part is to display the notification on our chat icon. So let's go back to our NextJS codebase. In the navigation component, this is our function to trigger the animation. And then after receiving the payload, we'll call this function. For example, let's call it handle echo callback. Let's create the function here. Let's call the set unread messages. We have a state here that I've already set up. Basically, it's just a count of unread messages we have received. So what we'll do is to increment this every time we receive a new message. So let's say prev unread, and then we'll just increment the current value. And then we'll also trigger the animation and the sound effect here. Sound.play. Okay, let's test it again. Refresh the pages, and you'll see there's one message already here because we have sent one earlier. Let's try it again. Send a message to Kiara. Yo, what's cooking? Send. Then in real time, there's our new message along with a simple animation and the alert notification sound. Let's try it again. Hello, Kiara. Send. Okay, there you go. We are properly receiving the messages, and when we click on the message icon, here are the recently received messages. Okay, in this example, we went through quite a few steps compared to the monolith approach in my last video. In the monolith approach, everything we needed to implement Laravel Reverb for receiving real-time communications using WebSockets was already set up. But this time, since our backend and front-end code bases are separate, this is what others commonly refer to as a decoupled architecture, we had to do a bit more steps. But as you can see in this example, it's not that difficult. Okay, so that's it, guys. I hope you learned something new from our simple example. And for those of you who have been asking how to implement Laravel Reverb in a Laravel application where the front end is separated from the back end, this is how you do it. And you can also use Laravel Reverb not just in the NextJS applications. You can also use it if you're using a front-end framework like Vue and Nuxt.js, for example. The concept of integrating Laravel Reverb is exactly the same. The same is true if you're using other frameworks like Svelte, Gatsby, or even Angular, as long as you can pull NPM packages. You can use Laravel Reverb in your projects regardless of the front-end framework you're using. Okay guys, if you liked the video and find it useful, kindly do me a favor and please like this video. And you can also consider subscribing if you haven't already. Thank you for watching, guys. See you next time.